So then rounded to 4 significant digits. So it's up to here. 1, 2, 3, 4. And this is 0. 0 is less than 5. So you truncate, get the answer. So you can see this probability is very small. Find the probability extremely small. Find the probability getting 8 or more than 8 questions correct out of 10 questions. Extremely small for this multiple choice question. Then question 8. If 5%, I change the number, 3% change to 5% of calculator, defectives, defective calculator. Find the mean, variance, and the standard deviation of a lot of change to 600 calculator. So first of all, you list out the given n equals 600. Probability for defective success, because here we want to find out the defective. So P is for defective is 5%. Change to decimal is 0.05. Q is 1 minus 0.05 is 0.95. So this is also each is two outcomes for each trial has 2 outcomes. So this is a binomial distribution. So we use the formula for binomial. Mean for binomial is equal n times p. N is 600, p is 0.05. Time together is 30, which is average is because 5% are defective, and then you have a 600 calculator. So average, mean is average. Out of 600 calculator, average is 30 calculator are defective. It's a mean. And the variance is NPQ. N is 600, P is 0.05, Q is 0.95, and time together is 28.5 calculators variance. And standard deviation is variance, take square root of 28.5. Got 5.3385. And we normally 4 significant digits. So 4 decimal digits up to here, and next digits 3 is less than 5. So those are truncate. Then question 9. Question 9 is regarding we call multinomial distribution. Multinomial distribution. Multinomial, binomial, multinomial distribution. If it is more than 2, if there are more than 2 outcomes, if 2 outcomes we use binomial. If the formula for 2 outcomes is this formula, binomial formula. For multinomial, probability formula is let me see, do they have this one? It's going to be this one, P of X, this one. And you can find out this formula in your homework formula sheet on the back. In your homework formula sheet here, this one. Multinomial distribution, this one. It's n, and then separate into x1, x2, x3 until xk. K, there's a P1, P2, P until K. Have a K outcomes, more than 2 outcomes. And here, summation of those xi, those x1 add x2 add x3 add xk should be equal n, total equal n, and the summation of those pi, those p1 add p2 add pk, it should be equal 1. And so this, use this formula, we can do this question. So this question, first of all, we have to figure out, because we use, so first of all, we figure out, here given, totally is 10 n and n, 10, n equal 10. And what is the probability of having 3 color each, or having 2 color each? Change it. Having 2 color each. So here has how many? 1, 2, 3, 4, 5. 5 colors. 5 colors. 2 color each. So 2 times 5. Total equal n. Summation of x altogether should be equal n. Now for the brown color, we call x1. Choose 2 of it. 2 of it. Then x1 equal 2. And for brown color, we call p1. Probability is p1 equal 18%. Change decimal 0.18. For the red color, also choose 2, because choose what is probability having 2 of each color. So x2 also 2 equal 2. P2 is 19%, 0.19. Then for the yellow color, we call x3 also equal 2. P3 is 0.2. 0.2 is equal 0.20. You can drop this 0. And the green is x4 equal 2. Probability is 21%, 0.21. For the orange, x5 equal 2. Probability also is 22%. Change decimal 0.22. So those probability, if you add together, should be equal 1. If not equal 1, then you cannot do it. You have to be equal 1. Then use the formula. Formula is this formula. N factorial, n is 10. N is 10. 10 factorial over x1, x2, x3, x4, x5. They are all 2. So it's 2 factorial times 2 factorial times 2 factorial, and etc. Times, first one, p1 is 0.18 to the power 2. x1 is 2. x2, 2. x3, 2. x4, 2. x5, also 2. Then probability, those probability, plug in and figure out this. So since 10 factorial is 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. 2 factorial is 2 times 1, which is 2. 2 factorial is times 2. Times 2 is 2. 2 times 1, so it's 2. And then they all have those squared. This exponent you can take out. And then those base tying together, because this is square, you go in each one, this square go each one, you got this one. Then now you take out 2, and those tying together first, that easier to calculate. Now you cancel 2. 10 divided by 2 is 5, 8 divided by 2 is 4, 6 divided by 2 is 3, 4 divided by 2, 2, 2 divided by 2, 1. And multiply those number out and use calculator, multiply this. Then you will get this number. And 4 significant digits up to here. And less than 5, so truncate. So it's 0.31132. And it's about 1.132% probability. So that is a multinomial distribution. And next one, question 10, we talk about, we call hypergeometric distribution. Hypergeometric distribution, we will use the formula. It's this one. So first of all, we have to figure out what is n, what is a, what is b, what is x. So the question is, if you can look at the notes, there's examples, have learning instructional materials in notes for question 10 and question 9. A recent study found that 2 out of every 12 houses, 2 out of every 12. So it's 12 houses, you separate into 2 houses and 10 houses. 2 out of 12 in a neighborhood have no insurance. So there's out of 12 house, there have 2 no insurance, 2 house no insurance. That is for A. B is half insurance, is 12 minus 2 is 10. So 2 add 10, A add B should be equal 12. A add B should be equal 12. There's 12 houses, have 2 houses, no insurance, A equal 2. And have 12 minus 2 is 10 houses has insurance. So 12 separate into 2 and 10. Now, if A houses are selected from those 12 houses, from those 12 houses, you select A house. In this A house, find the probability that exactly 1 uninsured. So x equal 1. So x equal 1. N is 8. Have A houses, you separate. 1 not insured. Insured is have insurance is 7. So for A houses also separate into 1 and 7. Looking for probability of exactly 1 uninsured. So looking for probability of 1. This is a probability when x equal 1. When x equal 1. When x equal 1. And n minus 1. N is 8. A minus 1, you got 7. 1 uninsured, 7 insured. So for the 12, you separate as 2 and 10. 2 is not insured, no insurance. 10 has insurance. And from 8, you separate into 1 and 7. Have 1 no insurance and has 7 house has insurance. So this, the denominator, which is a sample space. Total has 12 houses. You choose A houses. You take out A houses. So total combination is C 12 take 8. And 12 take 8, the formula to is here. C n take r equal n factorial over n minus r factorial times r factorial. You can switch the two because multiplication, you can change the order. This is C, like a C 12 take 8 is equal 12 factorial over A factorial, then times 12 minus 8 is 4 factorial. So C12 take 8 is equal this. That's total outcomes. You from 12 house, you select A house. That's total outcomes. And the probability 1 is among those A house have 1 exactly has 1 uninsured. And the remaining, the 7 is not, have 1 uninsured, have 7 has insured. So you are going to do is, because here from 12 houses has 2 house, no insurers. So you just 2 take 1. 2 take 1. There's 2, no insurance. You just want to choose exactly 1. So you take 2, take 1. So is combination is C 2. A is 2. And X is 1. So the C 2 take 1. 2 take 1 is 2 factorial over 1 factorial. 2 minus 1 is 1 factorial. You figure out this one equal 2. Equal to. Only 2 choice because it has a 2 house, no insurance. You choose 1. So you will just have 2 choice. So the C2 take 1. You only have 2 choice. No insurance, have 2 choice. Times has insurance. Because you have 8. You have 8 house. You choose a house from 12 house. In 8 houses, that 1 house need to be exactly 1 has not insured, no insurance, and remaining 7 need to be insured. So those remaining 7 house need to be get from 10, because there are 10 house has insurance. So you take 10 from 10 house, you take 7 house. Those 7 house has insurance. And so the C 10 take 7 equals 10 factorial over 7 factorial. 10 minus 7 is 3 factorial. So those are the how many outcomes have 7 insurance house. And those is how many outcomes has one house, no insurance. And that's 2, because only 2 has no insurance, so have 2 choice. And this is 2 outcomes, and 2 times this is A houses have exactly 1 has no insurance, have 7 has insurance from A houses. And the bottom, this denominator is total 12 take 8. From 12 houses, you take 8 houses, and those 8 houses, and they are mixed, have insurance or no insurance, have in the 8 houses have insurance or no insurance, or they all together. Total outcome is this. Then specific case is you want is exactly 1 no insured. So you have to, that one have come from no insurance. There's 2 no insurance. And that 7 has come from has insurance. Has 10 has insurance. Have 2 no insurance. 12 minus 2 have 10 have insurance. Those 10 has come from 10 insurance, have insurance house. So that's guarantee exactly 1 no insurance. The house no insurance. 1 house no insurance. Have 7 house has. So then total outcomes is tying together. Those is 8 houses, exactly 1 house no insurance. Have 7 house have insurance. And so many kind of combinations, so many kind of outcomes. All of the total this, so divided. Those are 1 factorial is 1, 1 factorial is 1, 2 factorial is 2 times 1 is 2. Times 10 factorial over 7 factorial over times 3 factorial. This one put over here, and 2 times 2 is this. Times this one reciprocal. Reciprocal. So 12 factorial put on denominator. 8 factorial times 4 factorial put on numerator. Then you do 2 times 10 factorial. You look at this 10 factorial, this 12 factorial, and this 12 factorial, you can put 12 times 11 times 10 factorial. And that 10 factorial with this 10 factorial, you can cancel each other. And a factorial, look at here, has 7 factorial. So a factorial, you can put a times 7 factorial. And that 7 factorial with 7 factorial, you can cancel each other. And this 4 factorial, you can put 4 times 3 factorial. And denominator has 3 factorial. 3 factorial and the 3 factorial cancel each other. So then you remain 2 times 8 times 4. Denominator have 12 times 11. 12 times 11. Cancel 4, get 1. 12 divided by 4 gets 3. So 2 times 8 is 16. 3 times 11 is 36. Then next one, we talk about its number question 11. It's the same. It's about the it's also the hypergeometric distribution. Hypergeometric distribution. Question 11. A shipment of 26 electric typewriters is rejected if 3 are checked for defects and at least 1 is found to be defective. So 26. Total has 26. 26. If you check 3. So n equals 3. N equals 3. And then we're looking for probability of x greater than or equal 1 defective. Find out the probability it's at least 1 is found to be defective. A shipment is rejected if 3 checked for defects. At least 1 is found to be defect. And if at least 1 is a defect, you'll return this shipment. So find the probability that the shipment will be returned. So it's find out probability of x greater than or equal 1 defective. That's what we are looking for. Because at least 1 is found to be defective, then reject the shipment. So reject. So we are looking for probability of x greater than or equal 1 defective. So if you do this greater than or equal 1, then that means you need to find out probability of x equal 1, add the probability of x equal 2, add the probability of x equal 3. Because 3 are checked. That is very complicated. But the easier way is you do total is 1 minus probability of x equals 0 defective. That will get probability of x 1 or more than 1 are defective. And just take off total is 1, you minus probability of x equals 0 defective. That will be 1 or more than probability, more than 1. 1 or more than 1 are defective. So you just need to figure out this probability x equals 0 defective. So how to do this? So first of all, you have to figure out n is 3. And here we're looking for 0 defective. So it's x equals 0 defective. N minus x is 3. 3 minus 0 is 3 here. Then what is A? What is B? Because here say 6. If there are so this 26 typewriter, exactly 6 typewriters are defective. So A is 6. And the 26 minus 6 is 20. 6 defective. You say there are exactly 6 typewriters that are defective. So A equals 6 and B equals 20. Not defective is 20. So in this shipment have 6 exactly typewriters are defective. So then 1 minus this 0 defective. So you go, denominator is a total 26 typewriters. You choose 3 typewriters to check. So it's a C 26 takes 3. That's the total is a 26 factorial over 3 factorial times 26 minus 3, 23 factorial. On the numerator is you need to be 0 defect. 0 defect, so you do, there are 6 defect typewriters. You choose nothing, choose 0 from it. And then times, that outcome will be just 1 because 6 factorial over 0 factorial, 6 minus 0 is 6 factorial, those two are same, cancel, and 0 factorial is 1. And this part is equal 1. Equal 1. So actually just this part. Now this part is a combination C20 take 3. You want 0 defective. That means you take out 3 typewriters. 3 are 0 defective. That means no defective. That means the 3 are not defective. So you do from not defective typewriters has 20. You take off 3 of it. Then the 3, they are not defective. From defective typewriters, you take off 0 of it and time together. This part is going to be 0 defective outcomes. 0 defective outcomes. So C20 take 3 is 20 factorial over 3 factorial. 20 minus 3 is 17 factorial. So among total combination 26 take 3 has so many combination. 20 are no defective. Not defective is 20. Total take 3. They all not defective. So those part is not defective outcomes over total. And this is a probability of 0 defective. And you figure out this. So then equal 1 minus, and this cancel is 1. 20 factorial over 3 factorial times 17 factorial times this part. This part use reciprocal. 26 factorial put on denominator. 3 factorial times 23 factorial put on numerator. Then 1 minus, so here you can see 3 factorial cancel each other. And 20, here is a 20 factorial. Here has, so you can put 20 factorial as a 20 times 19 times 18 times 17. Because denominator is 17 factorial. So you don't need continue, you just put 17 factorial. With this 17 factorial, cancel each other. Then this denominator here, you can see here has 23 factorial. So this 26 factorial, you can put 26 times 25 times 24 times 23 factorial. 23 factorial cancel each other. So then you remain 1 minus 20 times 19 times 18. Denominator remain 26 times 25 times 24. And cancel common factor. Cancel 5. 25 divided by 5 is 5. 20 divided by 5 is 4. 18 and 24 cancel common factor 6. 18 divided by 6 gets 3. 24 divided by 6 get 4. And then this 4 with this 4 cancel each other. So remain 19 times 3 and 26 times 5. So the 1 minus 19 times 3 is 57. 26 times 5 is 130. 1 minus it. So 130 minus 57, and you got 73 over 130. That's the typewriters. Probability of return the shipment. Question 12 is going to be we call Poisson distribution. So a recent study showed a certain area has an average of 1 robbery per, I changed the number, 21,000 people in a city of 84,000 people, and find the probability of the following. Use the Poisson distribution. Now here we talk about Poisson distribution. Poisson distribution is a specific case of binomial distribution. Poisson distribution is when the mean is also n times p. It is a binomial distribution, but when n times p is very, very small, tying together is less than 5, you can use, if the mean is less than 5, then you can use Poisson distribution to approximate the binomial distribution. So if the mean for binomial distribution is lambda, for Poisson distribution mean we use lambda. It's the same formula as binomial distribution mean, n times p. If less than 5, like this, given n is 84,000, then p is what? 1 robbery per 21,000 people. So 1 out of 21,000 is the probability for the robberies. So the mean is what? Mean is if you have 84,000 people times this 1 out of 21,000, 1 robbery out of 21,000, cancel it, you got 4 robberies. So 84,000 people, average is 4 robberies. 1 robbery, 21,000 for 21,000 people, so times by 4. So you got 1 times 4 is 4 robberies. 21,000 times 4 is 84,000. So 84,000 people, you have average is 4 robberies. And this 4 is less than 5. Use Poisson distribution instead of binomial distribution. And then because if you use binomial distribution, this question is very hard to use binomial formula to get, or use the table to get, because n is big, probability is very small. That table cannot get the answer. Binomial table won't have those n very big one, p very small one. We cannot look at the tables. So then we use Poisson distribution to approximate the binomial distribution. So what is the Poisson distribution formula? You also can find this formula on the back. Poisson distribution formula is here, this one formula. P of x lambda is that mean equals e to the power negative lambda times lambda to the power x factorial. Then x equals 0, 1, 2, and etc. Lambda is equal np. Use this formula to do. Now, let's see. For this one, we are looking 0 robberies. So x is 0. So look, this is the formula. Then x is 0, lambda is 4, equal to e to the power negative lambda. Lambda is 4, so negative 4 times lambda is 4, x is 0, plug in. So 4 to the power 0 is 1. 0 factorial also 1, so that's equal e to the power negative 4. And use calculator to get. Calculator you look at E. So see, this is the second color is blue, light blue. So on those you also have a blue color. Here has e to the power x key, blue color. So we need to press second first, second first, and press this. This is, they show e to the power. Now here's -4. The sign is a negative sign and the 4. Parenthesis, enter. You will get this 0.0183. And 4 digits. You can see this. And then next one, when x equal 1 robberies, and the lambda equal 4, and plug into this formula. E to the power negative lambda is 4, times lambda is 4 to the power x is 1, over 1 factorial. 1 factorial is 1. Then this is 4 to the power 1 is 4. 4 times e to the power -4. Is this one times by 4. You got this. This e to the power -4 times by 4. E to the power -4 is this number times by 4. You got this number. Then next will be when 2 robberies. So P, probability of x equal 2, lambda equal 4, that equal 2, and plug into the formula again. That's the formula here. So we got e to the power lambda -4. E to the power -4 times lambda is 4. X is 2. X is 2, plug in. X is 2, plug in, over 2 factorial. 2 factorial is 2 times 1 is 2. And e to the power -4 times 4 squared. 4 squared is 4 times 4 is 16. Then do 16 divided by 2 is 8. So it's 8 times e to the power -4. So actually it's the a e to the power -4 is this number times by 8. Times by 8. And you got the answer. And the D. It's a probability x or more robberies, which is equal x equals 3. X has to be 3 or more robberies, which is equal 3 or more than 3. So find out probability of x greater than or equal 3. Lambda is 4. So then if you find out probability of 3 robbery, add probability of 4 robberies, add probability of 5, and so on. That's take long to get the answer. If you plug it into that Poisson distribution formula, take each one have to figure out. So the easier way is do 1 minus probability of x less than or equal 2. So take off x greater than or equal 3, then you take off when 0 robbery, probability of 0, plus probability of 1 robbery, plus probability of 2 robbery. And those take off. That's remaining is the probability of 3 or more than 3 robberies. So you just need to do 1 minus probability of 0 robbery and take out 1 robbery, take out 2 robberies. So those 3 is previous. We already figured out ABC. So probability of 0 robbery, we got A. From A is 0.0183. So put over here. Plus probability of 1 robberies, we got 0.0733. So that's this one. Probability of 2 robberies is from C is 0.1465. Those add together, then subtract from 1. and you got this. That is the probability for 3 or more than 3 robberies. Question 13 also. It is we call Poisson distribution example. So 13. There are 200 typographical errors randomly distributed in 800 pages. So among 800 pages, there are 200 errors. So average per page, how many errors? So it's 200 over 800. So it's 1/4 errors per page. That's prop P. And here, find the probability that a given page, so n equal 1 page, has exactly 2 errors. 2 errors. So looking for x equal 2. X should be equal to. X equal 2. Now this use Poisson distribution because you check non-dot. You check n times p. N is 1 page. P is 1/4. Equal 1/4. Very, very small. Less than 5. So this use Poisson distribution to approximate the binomial distribution. So Poisson distribution formula. Here, P of x lambda equal e to the power negative lambda times lambda to the power x over x factorial. Plug in. X will use 2 plug in because 2 errors. X equal 2. Lambda use 1/4 plug in. So we got here. So we got e to the power negative lambda. Lambda use 1/4. Lambda to the power x. Lambda is 1/4. X is 2 over x factorial. 2 factorial. 2 factorial is 2 times 1 is 2. Then e to the power negative 1/4 times 1/4. 1 square is 1. 4 square is 16. And this divided, this goes 16 go to the down to the denominator, become 2 times 16. And numerator is still 1 e to the power negative 1/4. So e to the power negative 1/4 over 32. Then use calculator to figure out. Calculator would be this. And we are going to figure out e to the power negative 1/4. So use this second. Press second. This. They will take this e to the power x. Because this blue color, they will do this one, this blue one. Negative 1/4 and put the negative sign and 1 over 1/4, 1 over 4, put the parenthesis. This whole thing. And then you can put enter first. Then you divide it by 32. And got this. And round it to up to here. This is 7, so round up. 4 digits, 4 significant digits. So 7 round up. Okay, 0.02434. Now this is end of homework of chapter 5 examples.